Welcome to day 30 of our STL template library course. Today we will explore 4 powerful and incredibly useful utilities in C++: pair, tuple, array, and bitset. These containers are essential for simplifying complex data structures and improving both the readability and efficiency of our code. Whether we are grouping values, working with fixed size arrays, or manipulating bits, these STL utilities will help us write more expressive, efficient, and maintainable code. Why should we use these STL utilities in our code? Well, STL containers help simplify the complexity of our programs. They reduce competitive grouping, repetitive coding, enhance readability, and provide clear, high-level abstractions for tasks like grouping values or manipulating data at the bit level. By leveraging pair, tuple, array, and bitset, you make your code easier to understand, maintain, and optimize. These utilities are not only vital for real-world applications but also widely used in competitive programming, where space and time efficiency are critical. Let's start with pair. A pair is a simple yet incredibly useful container that can hold two values of possibly different types. It is defined in the utility header, and its primary use is to store two related pieces of data. For example, you might use a pair to represent a coordinate, a key value pair in a map, or even return two values from a function. You can easily access the two values in a pair using dot first and dot second. This makes it a great tool for quick, compact data storage. Moving on to more advanced pair usage. While pairs are commonly initialized directly, you can also use makePair for more clarity and automatic type detection. This is particularly useful when the types of the elements are not explicitly obvious. Pair also supports comparison operators, allowing us to easily compare pairs based on their first and second elements. You can even nest pairs to create more complex structures such as multi-dimensional keys for sorting or searching. Let's consider an example where we compare two pairs and check if one is greater than the other. Next, let's dive into tuple. Unlike pair, which can only hold two values, a tuple can hold any number of values, potentially of different types. This makes it perfect for situations where you need to group multiple values together. For example, you might want to return a student's ID, name, and grade from a function. The beauty of tuples is that they allow you to store heterogeneous data in a single object. You can access the tuple elements using std::get, or if you are using C++17 or later, you can use structured bindings for a more intuitive and readable approach. Tuples come with some incredibly useful utilities. For example, std::type allows us to unpack a tuple into individual variables, which can be very handy when dealing with function returns or complex data structures. If you don't care about certain values in a tuple, you can use std::ignore to skip them. Additionally, std::tuple_cat lets us concatenate multiple tuples into one, which is useful for combining different sets of data into a single entity. Now let's talk about std::array, which is a safer and more powerful alternative to traditional C-style arrays. Defined in the array header, std::array has a fixed size that is known at compile time. This gives us the safety of bounds checking when accessing elements, and it integrates smoothly with STL algorithms like std::sort, std::find, and std::for each. Unlike a regular array, you can directly use these algorithms with std::array, which makes it a much more modern and reliable choice for fixed size collections. With std::array, you gain access to several useful methods. For example, .size gives you the number of elements in the array, and .add provides bounds check access to elements. The .front and .break methods allow you to access the first and last elements respectively. You can also use .fill to set all elements of the array to a specific value. For instance, you could fill an array with zeros using fill 0 and access any element using add 2, all while avoiding common array related pitfalls such as out of bounds access. Finally, let's take a look at bitset. Defined in the bitset header, bitset is a fixed size sequence of bits. It is perfect for situations where you need to perform binary operations such as bit masking, cryptography, or low-level data processing. With bitset, you can represent binary data cleanly and efficiently. For example, you can create a bitset to store a binary value like 10101100 and then use the count method to count the number of bits that are set to 1. This makes it an ideal container for handling bit level manipulation. bitset comes with a variety of methods for manipulating bits. For example, .set lets us set specific bits to 1, while .reset sets bits to 0. Flip inverts the current state of the bits, and .tests checks whether a bit at a specific position is set. Additionally, .count counts how many bits are set to 1, and methods like .toString help us to convert a bit set back into a string for easy display or debugging. These methods make bitset incredibly versatile for bit-level tasks. Let's summarize the key differences between these containers in a comparison table. Pair is ideal for storing two related values such as key value pair or a coordinate. Tuple, on the other hand, is perfect for grouping multiple heterogeneous values together. Array is a safer, more efficient alternative to traditional arrays, while bitset is specialized for efficient bit-level operations. Understanding when to use each of these containers is crucial for writing efficient and maintainable C++ code. To solidify today's lessons, here are a few practice problems. Try using pair to represent the coordinates or graph edges. Use tuple to return multiple values from a function or to represent complex data. Replace old C-style arrays with array to take advantage of its safety features, and finally explore solving problems with bitset such as checking subsets or performing bit manipulation. To wrap up day 30, we have covered a variety of STL utilities that will make your coding more efficient and readable. pair and tuple allow us to group related values, while array provides a modern, safer alternative to traditional arrays. bitset offers powerful bit manipulation capabilities. Mastering these containers will give us the tools to write clean, efficient code, whether we are working on real-world applications or preparing for competitive programming challenges.